Come quite a long way since August of 2010. You can see beside me here is a ready-to-fly payload for SpeedBall-1. It's truly a robotic pilot for this unmanned balloon. We've done a lot of work since you've last seen pictures and video. This is the deployed configuration except for the lid of the box here. You can see the satellite modem antenna is here. The ballast bottle and payload is down below here. This contains messages in all the languages of Western Europe and Western Africa in case the payload is found by someone who doesn't know about the mission. And it tells them that it's a harmless device merely for civilian scientific exploration and to contact us for its safe return.
Let's take a closer look here at SpeedBall-1. As we can see here, I'll show you around. On this side, at the top, we have an interesting device. This is a sensor that allows us to tell when there's ice particles falling over the payload. We've read in some academic papers from France in the 1960s that they discovered that in the jet stream it's possible that cirrus clouds, the light, fluffy, thin ones you might see, can actually deposit ice on the top of the balloon in the form of almost a snow of fine crystals. And if that were to happen, our balloon would slowly sink out of the sky with no explanation to us, unless we had something that could detect little particles falling down through a hole, as this can. It's actually a dust sensor from a heating system. Down here you see a wire coming out, connection. This is how we talk to it when it's on the ground. We give it power and get it set up ready for flight on the way up to the launch site. Next to this is a very carefully taped switch that determines where the power for the whole payload comes from. Right now it's set and taped to the ground plug here. We don't want to use our batteries up inside. You'll notice this here. This is a jack that a pin will be pulled out of right at launch to tell the onboard computer exactly when it left the ground. And our ground crew will do that. And as we move up here, you can see these are the ropes that will actually support the payload to the balloon. There are 3 of them, you'll note, coming out of the top, and there's a special reason for that. These outer 2 are the ones that will normally be supporting it from the balloon. Both of those in tandem will bear the weight for most of the mission, while the 3rd one in the center here will actually be loose, although it will be tied to the balloon, but limply. It will go all the way up to the top of the balloon, outside of it. And when it's time to end the mission, if we need to terminate the flight remotely, this rope, these 2 ropes here that go in the outside holes there, are actually one rope. They go down, go across, and back up. And in the middle, there is a wire cutter, a melter, that will slice through that rope on command and allow both of these ropes to slide right out, and the payload will fall down and be supported by this rope only, which is connected to the top of the balloon, which will immediately put all the weight of the payload, 6 to 12 pounds, hanging off the top corner of the balloon. If you can imagine that, it's suddenly going to tip the balloon right upside down. And that will allow all the helium to escape out the bottom, what had been the bottom of the balloon, and start descending down, fluttering with the balloon above it to slow its descent. You see our trusty wooden stand here is actually built for transport. It is going to actually take the payload to the launch site in a van. It has casters so it can roll. Below here you see several things we'll take a look at. This is the strobe light. It uses 5 LEDs to indicate to aircraft that we're around. If there's any aircraft in the vicinity, this will be flashing all night long. Below this is a little custom-made solar shield. This protects our environmental sensors. There's a humidity sensor right there in the middle and a temperature sensor down here at the bottom. It protects these 2 sensors from the sun. Not that they'd be damaged, but the sun is extremely hot up at these altitudes. Even though the air is negative 40 degrees C and Fahrenheit, the solar radiation is intense. And because the air is thin, air movement doesn't cool things off very well. So these temperature sensors inside this thing would heat up extremely fast in the sun and give us a temperature that wasn't the actual air temperature at all, much higher. So this is supposed to shield it from the sun but allow air to flow through. This was made, by the way, right here at Level 1 Hackerspace on our MakerBot 3D printer. You can see a little bit of the texturing of the laid plastic filaments that were used to create that. And down below here you see the ballast bottle, the messages of greetings, I'm harmless, and our white star, and below that a black cone. This cone contains the valve that allows the alcohol to drain out. A little hole in the center there when the balloon computer indicates it needs to drain some alcohol. Let me grab one that's not already enclosed to show you what that actually looks like. Here we go. Here's one without all the wrappings. You can see the similarity. Take a look down here. There you see how it works. That's the secret to staying up in the air. This little black solenoid electric valve opens up that rubber drain tube and allows the denatured alcohol to drain out on command, lowering the weight. We'll take a quick look inside now. It's quite a tangle of cables that are used for testing right now that won't be there during the real flight. But you can see all the boards that we've built and worked so hard on over the past couple of months. The one you see right up top here, the yellow one, is the board that I mentioned previously. This is the cut down board, which actually will slice through the rope when it's time to do so. Here's a nice view of the cut down board. You can see this rope right ahead. It has a couple of black lines cutting across it. That's actually the wire that will heat up and melt right through that rope. And it will come right up through here and pull right out, as you can see. To give you an idea of how this is constructed, this is the box that's already been made for SpeedBall-2, our second flight to come after the first one. This is identical to the box that you just saw on SpeedBall-1, but without all the stuff inside, so you can see how it's made. This is actually made of pink foam building insulation. I'll show you, I've removed a side already. You can see what's going on in the inside. You can see there's a tray down below which actually bears all the weight of the 54 AA's and the electronics. You can see the cut down board circuitry is already installed up there. And these pink foam insulation boards are mortise and tenoned through a special tool process that one of our guys built, which you can see in another video online. Here in the midst of the Level 1 hackerspace, what looks like a computer lab is actually the White Star Mission Control. You can see we have our very own big board up front and many stations for the various functions of the flight that will be required.